In this series of videos, I'm going to do some algebra review, some things you should have seen before. In the first video, this one in particular, I'm going to focus on common mistakes that people make. And so I'm going to take a look at a bunch of different things where you might think two things are equal. I'm going to show you that things are in general not equal. So take a look here. Common mistake that people might think is that square root of x plus y is equal to the square root of x plus the square root of y. But these two expressions are actually not equal. To see this, let's see that we can set, for example, x is equal to 16 and y is equal to 9. If we make those choices, square root of 16 plus 9 is going to be square root of 25 is equal to 5 on the left, whereas on the right, the square root of 16 plus the square root of 9 is equal to 4 plus 3 is equal to 7. And these two numbers, 5 and 7, are not equal to each other. So you ever see square root of x plus y, you need to know you cannot rewrite that as square root x plus square root y. Here's another one. Suppose that you have an expression a over x plus y. Is that equal to a over x plus a over y? Can you break things up in the denominator like this? Answer is no, you cannot do that. To plug in values to see that this is not true, let's use a is equal to 1, x is equal to 1, and y is equal to 1. So we set everything here equal to 1. We get 1 over 1 plus 1 on the left. On the right, we get 1 over 1 plus 1 over 1. Now, 1 over 1 is 1, plus 1 over 1. 1 plus 1 is 2. 1 over 1 plus 1 is 2. This is 1/2. So on the left, we have 1/2. On the right, we have 2. And those two things are not equal to each other. A squared plus b squared. Is this equal to a plus b quantity squared? No. Let's try a is equal to 3 and b is equal to 4. In that case, we have 3 squared plus 4 squared on the left and 3 plus 4 squared on the right. So over here, 3 squared plus 4 squared is 25. 3 plus 4 is 7. 7 squared is 49. 49 and 25 are not equal to each other. So these two expressions are not equal to each other. Okay, let's do a couple more. The next couple will have to do with trigonometric functions. Is sine of x plus y equal to sine of x plus sine of y? Can we distribute this out like this? And the answer is no, we can't do that. These two expressions are not equal to each other. As a counterexample to this, let's try x is pi over 3 and y is pi over 6. So in that case, we would have sine of pi over 3 plus pi over 6. And on the right, we'd have sine of pi over 3 plus sine of pi over 6. Now, pi over 3 plus pi over 6, that's pi over 2. So now we just need to fill in sine of pi over 2, sine of pi over 3, and sine of pi over 6. These are all good things to have memorized, these trigonometric function values. Sine of pi over 2 is 1. Sine of pi over 3 is root 3 over 2. And sine of pi over 6 is 1/2. And 1 is not equal to root 3 over 2 plus 1/2. So sine of x plus y is not equal to sine x plus sine y. Cosine of ax, is that equal to a cosine of x? Can you pull an a outside of the cosine? And so the answer to that is no, you can't. These two expressions are not equal to each other. As a counterexample to this, try a is equal to 2, x is equal to pi. So we'd have cosine of 2 pi. Is this equal to 2 cosine of pi? So the answer is no. Cosine of 2 pi, entire loop around the circle, cosine of 2 pi is 1. Cosine pi is -1, so it's 2 times -1 is -2. And so these two expressions are not equal to each other. And then finally, our final example here of two things are not equal is a times square root xy equal to square root of a squared x plus a squared y. So the answer is no, but this is close to being right. And so the only way that this would fail is if a is zero. Sorry, if a is less than 0, if a is negative. So if we try a is equal to -1 and x and y are both 1, we would get -1 times square root of 1 plus 1 and -1 squared times 1 plus -1 squared times 1. So on the left, this is negative square root 2. And on the right, this is -1 squared is 1, 1 plus 1 square root 2. So negative square root 2 is not equal to the square root of 2. Let me just observe here that the way to patch this up, this fails. This fails because a is negative. And so the way to patch up the expression here is square root of a squared x plus a squared y. So we can factor out an a squared here. Square root of a squared times x plus y is equal to square root of a squared times square root x plus y. And the square root of a squared is not always equal to a. It's equal to the absolute value of a. So this is a useful fact to know. The square root of a squared is the absolute value of a. And we saw this was important right here, and we use a as -1. Okay, so hopefully this was an instructive video showing you how to avoid some common traps.